Hey guys, this video covers arrays, a bit of, I guess, notation or vocabulary or just facts about arrays. Arrays are zero index, just like we do with strings, meaning the first element has an index of 0 and the last element has an index of 1 less than whatever the array size is. Arrays can only hold one type of variable. So if we have an array that stores a bunch of integer values, we can't put doubles in with that. We can't mix strings and ints. They only have one data type they can hold. The proper declaration for an array is you have to first state what kind of data type you have. You name the array whatever you want to name it. This box is important. It's just two open and close bracket, and it equals new, and again, whatever the data type is. So if this was an integer, we'd have int right here, and we'd also have int right here. And the last part is you put in the number of elements if you're going to later update the array with some different values that you like probably read in through some for loop. For small arrays, you can just set the array as you type it. We'll see that when we get going. If when we declare an array, we don't put anything in it, but then for whatever reason you try to print or access some value that's in the array, they're going to be like default values that the array store. For a string, you'd see it would return null in a position if there was something, if you tried to access, for instance, whatever array name you have at index 0, but there's nothing in there. The value null is stored in there, so something is taking up memory space. For ints, that default value is going to be 0. For doubles, that default is going to be 0.0. And for booleans, the default value is going to be false. And we haven't talked much about chars, but for a char, the default value is just, it's a blank, it's a space. There's nothing printed there. So when we get down here, if we wanted to make an integer array, for instance, we would have int, and say we call this digits. So int digits, so we have to put in this open and close bracket, and then it equals new. And since we are storing integers, we're going to put int. And say I wanted to put in the digits 0 through 9, I would just say that I'm going to store 9 values here. Now, there are two ways that we can actually put values into this array. One way is we can make a for loop. We could do for int I equals 0, I is less than 10. We're going to do I plus plus, and so now we get into some different notation. We're going to have, so since the name of our array is digits, we do digits, and I is going to access the index for the array. So since our I starts at 0, when we do digits I, we're going to start at the first value of the array and keep going until we get to the end. We actually should make this 10 so that it holds the values 0 through 9. So we're going to have digits I equals I. So what we're telling the computer is to store the value of I in that same index value. So like digit 0 is going to store 0, digits 1 is going to store 1, and so forth. And so then when we come down here, if we wanted, we could do for int j equals 0, j is less than 10, j plus plus, and we could do digits j. You know what, actually we'll do, so it doesn't go to a new line, we'll just do print line, and we will separate these with a space. So right now, if we run this, we will get the digits 0 through 9. So arrays are they're primitive data structures. They store things, like you could think about it as they store them in a row, since it's a one-dimensional array. They're useful for holding all kinds of data, strings, ints, doubles, whatever we want. And it allows us to access stuff instead of storing everything in different variables. We can put them all in just a single container, and we can save them for access later. So going back to the other way we could have updated this array with values is because it's such a small array, it's possible to just go ahead and enter the values as you declare the array. So we could have had int digits equals, and instead of this new int thing, we could have just done 0, and then we separate all of our values by commas. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And what this does, it does two things. One, it puts all of the values in the array, and it also automatically like tells the size of the array. In this case, that would be 10. So if we came back and we made a different loop, I'm not sure why I deleted the other one. And we still print the value in digits at the appropriate index. When we run this, we'll still get the exact same thing, 0 through 9. So for small arrays, it could be useful to just go ahead and put all of your values in the array as you declare the array. But generally speaking, our arrays are going to be dependent upon some other sort of calculations or user input. So we generally just declare the size of the array and then later on go through and put things in the array as we need to. So the other thing is that just like a string has a length, arrays have lengths as well. And we would know that if we type in, I don't know, string word equals letters, and we said x equal, actually we could just do a print statement, and we did word dot length. The dot length method for a string has this open and close empty parentheses at the end, and when we print this, we expect to get 7. Actually, so let's comment this out for a moment. We can just delete it. We need to comment it out. So we're done with that digits thing for a moment. So when we go back and run this, we get the 7 that came up with at the end of this array line was the length of the word. So for digits, if you want to access the length, it is whatever the name of your array is, in our case, digits. And we would do just dot length. And you see it finishes it for us. And digits dot length has no, for an array, there is no open or close parentheses at the end. And we expect this value to be 10. So we run this and we get 10. So if we were going back and printing this, we'd have int I equals 0. And now if we want to print to the end of our array, we can say I needs to be less than digits dot length. And if we wanted to print every other value, for instance, we could do plus equals 2. And we can say print digits I, and it would skip. So we expect to get just the even numbers this time. And when we do that, that's what we get. We get 0, 2, 4, 6, 8, 10. And when we there's another kind of loop. They call it an enhanced for loop. And you can use this for any sort of data structure in Java. So arrays are the first data structure that we cover. So another way to print the values of an array without having to do 2 lines is we can knock this down to a 1-line statement where we could have 4 So when you do an enhanced for loop, you have for whatever data type that you have, and then you come up with, like in this case, our array digits stores numbers. So we say like num, and we have an open colon, and then after the, not an open colon, just a colon, and we have after this we need the name of the data structure that we're going to refer to. So we would have for int, and then just whatever placeholder name you want to use for the values in your array. We could have said this is X or anything, but it makes sense that we have digits that we call them numbers. So for int num, and the colon kind of means in digits, in the array digits, and we can tell it to do something. We don't need this open brace anymore because we're only going to have one line. So we could say print just num. And what this is going to do is start at the beginning of the array digits and print everything in that array. And when we run this, we get the same thing. But again, so we can actually see this, we'll just change this slightly. And we get 0 through 9. So again, this is what we call an enhanced for loop. Again, the shorthand for this is for, and you have your data type. You have we'll say just a nickname for whatever you want to call the things in the array, and actual array name. And after this for loop, if you have a couple of lines of code, you need an open bracket, open and close bracket or brace to do whatever you want inside of that loop body. But it's going to be handy for us if we can learn to use this. We'll see this again when we talk about two-dimensional arrays and array lists. The last thing that we'll cover is you can have a method return an array. And so to do this, we're going to import java.util, and we're going to bring in the random. And so we're going to create a method. We're going to just say public, not public, we want static int, and we'll just call this randoms. And so what we want to do is return random values from 1 to 100. So we're going to have random equals new random. And then we're going to create an integer array. We're going to say int, we'll say int, we'll just call it 100 equal, so again, because it's an array, we need the open and closed bracket. So int 100 with the box equals new int. And if we want to store, say 100 values, we'll just put in 100. We have this. And so now if we want to put in random numbers, we could say for int I equals 0, I is less than 100 dot length I plus plus, and we want every value of the array to be some random number between 1 and 100. So we're going to do random dot next int, and remember the values for random int is the maximum value minus the minimum value plus the minimum. So instead of doing 100 minus 1, which the computer would gladly calculate, we're going to do random from 0 to 99 plus 1. So when we so this is going to generate a random number between 1 and 100, and then we will return what's the name of the array? 100. So we want to return 100. And oh, I forgot to close this out with a semicolon. So now we have a method that just generates random integers from 1 to 100. When we, back in our main method, then we could make an integer array. We'll call this int, we'll call it trial, and it equals. So if we're declaring an array from that is going to use a method to create the array, we don't have to worry about the other syntax that we talked about for array. We can just say this equals randoms. And what's going to happen is that Java knows to create an array based upon what this method does. And so then when we come down here, we're going to have for int, we're going to have random and some random number in trial. We want to just print those values in trial. So we're going to do print random, and we're going to separate them by a space. You know what? So this is actually smaller, so we can see it. Let's make this array size 25 instead. So we save this and we run it, and we get a bunch of different. I don't have this spaced out. Space. So now when we see this, we get random numbers from 0 to 100. We have 18, 22, 4, 36, and so forth. And it's all just done. Creating the array is done in this method called randoms. And if we came along and type a different, we can have int another equals randoms, and we're going to just copy and paste this. Let's see, we'll put this right here. But we don't want to do this in trial. We want to do this in another. And we'll just put a print line statement right here to get two different lines. So when we run this, we get two different arrays that are accessing the same method, and they clearly print different values. So again, to recap what we do with arrays, we first declare where's the method? So we declare the data type. The name of the array can be whatever you want. I would make it something that's going to be so that you know what the array is going to store. And you have new data type. And if you're not going to put the values in, you have to declare the size of the array ahead of time. And again, when we say this is dynamic, once this has 25, we can't add anything to it at the end. Like if I try to do 125 equals 9, for instance. So this value 25 isn't since arrays are 0 indexed, it's going to go from 0 to 24, and you can't actually add anything here. We get some sort of error if we try to run this. So if we see this down here, we can go back and even see this here. So since both of these arrays store 25 values, if we did trial, we could try to print trial 27, like some value that we know is not in the array. So we're gonna get we're gonna get an error because that's not a thing. Let's take this out. And so now seemingly this is going to work because we don't get any error message, but this is going to be what we call a runtime error, that when the computer hits, it's going to say, I can't do that. And so it's going to throw us this exception that's out of bounds, and it's at line 42. And what's happening is that when you see this out of bounds instance, it's going to tell you what it can't access, which in this case is 27, because our array only has 25 values. And even if we go back and change this to 25, when we run it, it's still going to give us the same thing, because Again, arrays are zero index, so to go up to we go from 0 to 24 instead of 1 to 25. So now if we came back and made this 24 instead, everything is going to run just fine. It's going to give us that fit, like these two 50s is going to give us those two things twice, because this is the 50 from the for loop and this 50 is from us printing this line. So now again, with arrays, you can store anything. We only did this for ints, but you can put in strings, which would be helpful in the programs that you all are writing right now. We can do this with doubles and Boolean values. So be creative. We learned a really good data structure. Later on, we'll talk about how we can search and sort these. See you guys in class.